The laboratory clock ticked with a heavy, rhythmic pulse at 3 in the morning. Dr. Aris stood alone before the microscope, his tired eyes fixed on the glowing monitor. On the screen, a sample of motor neurons from an ALS patient showed a catastrophic collapse. Inside these fragile cells, the TDP-43 protein had escaped the safety of the nucleus. It was clumping into jagged, toxic fibers that choked the cell to death. For years, the scientific community had tried to scrub these toxic clumps away, only to watch them reform like shadows in the night. The silence in the room was absolute, save for the hum of the machinery and the weight of a decade of failed experiments. Aris adjusted the focus, his fingers moving with surgical precision. He was about to introduce a microscopic strand of RNA, a molecule he had meticulously engineered and named Malat-1, START. This was not a detergent to wash away the waste, but a chaperone designed to guide the lost proteins home. He held his breath as the needle engaged. "This has to be the one," he whispered to the empty room. He watched the screen, waiting for any sign of change. The jagged fibers remained still at first, mocking his efforts. Every second felt like an hour as he monitored the chemical interaction at the molecular level, looking for the slightest ripple in the toxic architecture. Slowly, the impossible began to happen. The rigid fibers started to vibrate, as if responding to an invisible frequency. Within minutes, the toxic aggregates that had once been solid and deadly began to dissolve into a fluid mist. The TDP-43 molecules, now restored to a soluble state, drifted back into the nucleus, reclaiming their rightful place in the heart of the cell. It was a beautiful, chaotic dance of recovery. The cell, previously dormant and dying, suddenly surged with life, resuming its vital RNA processing as if awakening from a long, dark coma. Aris stepped back, his hands steady for the first time in weeks. He immediately turned his attention to the mouse model nearby. The subject was already showing signs of advanced motor degeneration, its limbs heavy and unresponsive. With a steady hand, he administered a single dose of the RNA chaperone. "Let us see if you can find your way back too," he murmured. 2 weeks later, the physical results were undeniable. The mouse, which had previously been struggling to move its tiny limbs, now navigated the complex maze with newfound strength and agility. Its movements were fluid, its energy restored. The data was clear. The motor neurons were no longer dying, they were actively regenerating. Aris watched the mouse climb, realizing that the boundary between terminal illness and recovery had just been erased. The biological clock was not just stopping, it was winding back. The laboratory was no longer a place of observation for death, but a witness to the persistence of life. The implications rippled far beyond ALS. Aris looked at the data on his desk, seeing the same protein pathology in Alzheimer's and FTD patients. By stabilizing a single protein, they had found a master key to the mind. He closed the lab door, knowing the frozen world of these patients was finally beginning to thaw.